This is the video solution to an example problem with conservation of mechanical energy. The Valles Marineris is the deepest canyon on Mars. Its maximum height to its floor is 10,000 meters. This is 5 times deeper than Arizona's Grand Canyon. That makes this canyon on Mars about 5 miles high, or 5 miles deep. The atmosphere on Mars is very, very thin. Neglecting air resistance, how fast would a 2.5 gram penny be traveling when it hit the floor of the Valles Marineris if it was dropped from the highest point? Martian gravity accelerates all objects down at 3.88 meters per second. So I'm going to pick two locations to compare where I know the height and the velocity. So I'm going to pick the highest point and the lowest point because that's what the question is asking about when it hits the lowest point on the floor. So I'll compare the mechanical energy on the highest point, which is the ledge, and set that equal to the mechanical energy, the sum of all the mechanical energies on the canyon floor. So that means kinetic plus potential energy stored in gravity is equal to kinetic plus potential energy stored in gravity. In order to figure out which of these I have at the two locations, I will ask two questions about each location. First question is the penny moving at the highest point? And it's not, because it says it was dropped. And whenever something says it's dropped, that implies that the initial velocity is equal to 0. So that kinetic energy at the ledge is going to go away. Next question. At the ledge, is the penny above the other location? And it is. So I'm going to keep the mechanical energy stored due to gravity. Next question about the canyon floor. Is the penny moving at this location on the canyon floor? And the answer is yes. When it impacts the canyon floor, it is moving. A moment later, it's not, but when it hits, it is. So I'm going to keep that kinetic energy. Next question is, at this spot, is it above the other location? In other words, on the canyon floor, is the penny above the other location? And it's not. It's the lowest of the two. So that's going to go away. So now I know that mgh is going to be equal to 1/2 mv squared. That is, potential energy due to gravity from the ledge is equal to 1/2 mv squared of the penny when it impacts the canyon floor. Since it's the same object in both locations, the penny, and the mass doesn't change, I can see there's an m in every expression, so I can divide out the masses. So gh is equal to 1/2 v squared. Isolating v gives me the square root of 2gh is equal to v. Plugging in numbers and units, doing a little bit of math, I can see the penny is going to hit the canyon floor at 279 meters per second. That's over 500 miles per hour, in case you're wondering. And notice that when I'm doing these calculations, I don't put a negative value in for gravity or the height. Energy is a scalar, and all the signs are actually figured out in the logic of how we set up each problem in this problem. So don't put in the negative signs for g and h.